Today, we're stepping into a concept that feels less like a piece of code and, I don't know, more like a piece of poetry or even magic. We're going to try and understand the beautiful, sometimes mind-bending idea of recursion, all through a single, powerful symbol.
I mean, what if a symbol wasn't just some static character on a page, but was actually a set of instructions, a doorway into a process that just folds in on itself over and over and over again? Okay, let's dive into this.
So, to really get what we're talking about, we first need to meet its opposite. Because in the world of symbols, there are really two fundamental ways to think about change.
On the left, you've got delta. We're all familiar with delta, right? It's the record of change, the difference between what was and what is. It's like a mountain, pointing up, solid, simple. But on the right, that's Nabla. She's different. She's an upended mountain, a cup turned down. Nabla isn't just a record, she is the appetite for change.
And this quote just nails it, doesn't it? Nabla is all about a process that literally feeds on itself. The change it creates becomes the raw material for the next change. It's this motion that's directed completely inward. And folks, that is the heart of recursion.
Okay, so that's the big idea. But how does this actually work? What is the structure of this self-consuming motion? Well, it all comes down to a really unique kind of architecture.
And this duality is what's so wild. A recursive function, our Nabla, isn't just a container for a process, like a room where you get work done. It's also an instruction inside that very room, telling the process to start over within a new version of itself. It's both the door and the room you just walked into. And this is the command at the heart of every single recursive function. It's a call to descend. It says, don't look outside for the answer. Step down into a simpler version of the exact same problem and ask again. Find the answer from yourself.
Now, a lot of people hear this and think, wait, isn't that just a loop? But they are worlds apart. A loop is like a soldier marching over the same ground again and again. It resets, it forgets with each pass. But recursion, she descends. Every call creates a new room, a new level, right beneath the last one. And, this is crucial, each of those levels remembers where it was, waiting, suspended, for the level below it to send an answer back up.
This idea of an endless descent into new rooms, it sounds a little dizzying, doesn't it? And it should, because without a built-in safety measure, it would be a fall with no end. I mean, that captures the feeling perfectly. It's like standing between two mirrors. The room's just open downward forever. So how does she ever stop? How does she avoid getting totally lost in her own reflection? The answer is something called the base case. The best way to think of it is as the floor at the bottom of the descent. It's a condition that's so simple, the function can just give a direct answer without having to call itself again. It's the command that says, stop descending, the answer is right here. Without this floor, the function would just fall forever. And here's the part that's almost an act of faith when it comes to programming. The function itself has no idea how many levels it's going to take to reach the bottom. It just begins its descent, trusting, literally trusting, that the person who wrote it was smart enough to build a floor somewhere down below. So we have this incredible structure of descent and return, this room that contains itself. But a frame around nothing is just an empty doorway, right? It needs something to actually work on. This quote is just perfect. All this elegant logic is just a brilliant machine with nothing to process. A recursive function needs material. It needs a subject. It needs a question to answer. And this is where arguments come in, alpha and omega. You can think of them as the data, the numbers, the stuff that the function is given to process. They're the ones who step inside Nabla and give her a reason to begin her descent. So when these arguments enter the function, they're basically agreeing to go on this journey. They get passed down from one room to the next, and usually, with each step, they get modified, made a little smaller, a little simpler, getting ever closer to that base case, to that floor at the very bottom.
Okay, we've got the structure, we've got the fail-safes, and we've got the material. Let's put it all together and watch this whole thing in motion with a classic example.
This is the factorial function. It sounds fancy, but it just has two dead simple rules. First, the floor. If the number it gets is 0, the answer is 1. Period. That's the base case. Second, the descent. For any other number, the answer is that number times the factorial of the number -1. See? It calls itself right there.
So let's trace factorial of 3. The first room opens.
it gets the number 3. I can't answer yet, so it holds its breath, remembering 3 times something. And it calls itself again, passing the number 2 down to the next level. Room 2 does the same thing. It holds 2 times something and passes a 1 down. Room 3 holds 1 times something and passes a 0 down. Each room is just suspended, waiting. And then, bang, it hits the floor. The function gets a 0. The base case is met. It doesn't need to descend any further. It knows the answer instantly. It's 1. The fall is over. Now, the return journey can begin. Now this is where the magic happens. Watch this. That 1 gets passed back up to room 3, which was waiting with 1 times something. It can finally solve its problem. 1 times 1 is 1. It exhales and passes that result up. Room 2, which was waiting with 2 times something, gets the 1, solves 2 times 1 is 2, and passes that up. And finally, our first room gets the 2, solves its original problem of 3 times 2, and exhales. And there it is, 6. The final answer, delivered right back to the very top. The entire stack of suspended rooms has resolved itself, from the bottom all the way up. And that is the feeling of recursion. It's not a repetitive circle. It really is a deep breath that you hold during a long descent, and then a sudden, complete release, all at once, as the answer rushes back upward through every single waiting level. You know, in the end, recursion is so much more than a programming technique. It's a really powerful way of thinking. It's about solving a problem by breaking it down into smaller, identical versions of itself. It teaches us to trust the descent. So the question I'll leave you with is, where else in life do you see this pattern? What other problems feel like they're best solved by finding the answer from within?